This lesson is all about exponential growth. Take notes on the video while you watch this. Exponential growth occurs when a quantity increases over time. Another word for that could be grows. This equation is used for exponential growth in real-world situations. So this equation, y equals p times 1 plus r raised to t, still represents an exponential function because we can still look at this as a times b to the power t, or x. Now, p, r, and t are very important pieces of information that we see in the real world. P comes from the word principal, and that's just an initial value or a starting amount. So P is very important because that's like our A value. R, which you might have guessed, is the rate. So in this case, it's going to be the growth rate because we're talking about growth functions. Now, when R is in the equation, it's going to be a decimal number. So we're going to do some converting between percents and decimals as we go through this lesson. The next important thing is t. T represents typically some amount of time as your exponent. Now let's look at a real-world example and what to do, how to use this equation to set up our exponential growth function. In this example, if the initial value is $1,200 and is growing exponentially by 5% each year, find the amount after 2 years. So I have some steps listed for you on the left, and we're going to do the work for this on the right-hand side. So first, we're going to need to write our equation because this is a growth function, an exponential growth function. So since this is growing exponentially, and we were told that in the problem, that means we're going to need to write down y equals p times 1 plus r to the power t. Next, we need to identify p, r, and t. So we're going to start with finding p. Our p value is always the initial value, the initial amount. So our initial value in this problem is $1,200. Okay, so P is $1,200. Now we need to know what the rate is. We were told that that amount, that initial value, was growing by 5% each year. So 5%, that is our growth rate. Now remember how I said, whoops, not 9%, 5%. Remember how I said that when you put your growth rate into the equation, we have to turn it into a decimal number. So to do that, we're going to take that 5% and we're going to divide it by 100 to find that percent as a decimal. So we're going to take 5% and divide it by 100. And that's going to give us our rate as a decimal. So I'm going to pull up Desmos and type in 5 divided by 100. So that is 0.05. So my rate as a decimal is 0.05. Next, we need to identify what amount of time are we given. So T is what we're looking for next. It says to find this amount after 2 years, so T is going to be 2 years. Now, since we have P, R, and T, we're just going to plug that information into our equation. So we're going to write y equals P is 1200, parentheses, because we're multiplying 1 plus the rate, which was 0.05, raised to the power T, because T was 2, so 2 is our exponent. Now, you can take all of this information and type it into Desmos so that you can evaluate or calculate that total amount. So we want to know what is 1200 times 1 plus 0.05 raised to the second power. So in Desmos, I'm going to type all of that in. Now, I don't need to type y equals. I'm just going to type in the values that I want. Okay, so I'm going to type in 1200, parentheses, 1 plus 0.05, close my parentheses. Now I need an exponent. So to get an exponent, whether it's 2 or a different exponent, you can click where this says a to the power b. And notice that gives me my cursor in the exponent position. And our exponent here is 2. So that total amount is $1,323, $1,323. Now, if I wanted to put that back into context, then that would mean that after 2 years, the amount is $1,323. And that would be what your final answer would look like.